Hello, this is Srivanth. I am from Saitechinfo and I am here to explain you about the chapter electricity. I'm not going to fully explain the chapter. We are just going to see the particular topic, that is factors that are affecting the resistance of a conductor. So, in this video blog, we are going to see three questions based on that, and a concept map, and finally IMPM. So, hope you'll find this topic interesting. So guys, let's go with the terms and definitions on factors that are affecting the resistance of a conductor. We know that rho is the electrical resistivity of a material of a conductor, and L is the length, A is the area of cross section, and R is the resistance. So ohm is the SI unit of resistance. Now, what is resistance? Resistance means it's a measure of opposition force to a current in a electric circuit. So basically there are four reasons where it affects the resistance of a conductor: material of which the resistor is made, thickness of resistor, and length of resistor, and temperature of conductor. So these are the four main reasons which affects the resistance of a conductor. Now let us see the first question. The question is: a copper wire has a diameter of 0.5 millimeter and resistivity of 1.6 into 10 power minus 8 ohms. What will be the length of this wire to make its resistance 10 ohm? How much does the resistance change if the diameter is doubled? So we know that R is equal to rho into L by A, where rho is the resistivity of copper, which is nothing but 1.6 into 10 power minus 8 ohms. R is equal to 10 ohms. So radius of wire is equal to 0.5 by 2 millimeter, which is nothing but 0.25 millimeter or 0.0025 millimeter. So we know that the area of a circle is pi r square. So pi is nothing but 3.14. So multiplying by 0.0025 the whole squared, which gives us the answer of 0.0000001962 meter square. So we know that L is equal to R into A divided by rho, which is nothing but 10 into 0.0000001962 divided by 1.6 into 10 power minus 8, which is nothing but 122.72 meter. If the diameter R is doubled, the new radius is 0.05 millimeter, which is nothing but 0.0005 meter. So the area of circle is again pi r square. So multiplying this by 3.14 into 0.0005 the whole squared, which gives us the answer 0.00000785 meter square. So the new resistance is R is equal to rho into L by A. Substituting the value, we get the answer as 25 ohms. The new resistance of the wire will be 25 ohms. Now let us go with the second question. A wire of given material having length L and area of cross section A has a resistance of 4 ohms. What would be the resistance of another wire of same material having length L by 2 and area of cross section 2A? We know that R is equal to 4 ohms. To find the resistance of new wire, the solution is R1 is equal to rho into 1 L by A, which is equal to 4 ohms. Now R2 is equal to L by 2 divided by 2A, which is nothing but 1 by 4 is equal to rho into L by A. R2 is equal to 1 by 4 into R1. R2 is equal to 1 ohms. The answer is 1 ohm. Now let us see the last question of this video. Question number 3. Resistance of a metal wire of length 1 meter is 26 ohms at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at the temperature? Predict the material. So given R is equal to 26 ohms and diameter is equal to 0.3 millimeter and length is equal to 1 meter. We know that rho is equal to R into A divided by L, which is nothing but R into pi d square. So now we have to find the material of the wire. The solution is rho. We already know the rho, that is nothing but 1.84 into 10 power minus 6 ohms. By substituting the value, we get the metal names, cause the resistivity of the metal is 1.84 into 10 power minus 6 ohms at 20 degrees Celsius. So we can easily predict the metal, that it is manganese. Now let us see a MPM for a better understanding. MPM is the model problem mapping. So what is an MPM? MPM means if you have a formula and if you are given with two values, you have to remodify the formula to get the third value, right? So that is the MPM. So See, I have the formula R is equal to rho into L divided by A. To find resistance, I'm putting the formula same. To find the area, I'm putting that A is equal to L into rho divided by R. To find the length, I'm putting that L is equal to R into A divided by rho. So, if the all are the same material, if R1 is equal to R is equal to rho, I'm putting that R1 divided by R is equal to L1 into A is divided by L into A1. Hope you understood. At last, we'll see a quiz for the factors affecting resistance of a conductor. So, hope you like the quiz. And if you like the video, kindly do share, subscribe, and like the video. So, thank you. Thank you for watching.